Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 103. Binary tree zigzag level order traversal. Given the root of a binary tree, return the zigzag level order traversal of its nodes value. That is from left to right, then right to left, next level, alternatively. So first it will be what? Left to right. Then it will be right to left. Then again left to right. Then again right to left, like that. Now, take for example, this is our tree. Okay, now I can say this one level, and this one level. Okay, now in first level, I should do what? Left to right. Left to right. Okay. At second level, it is right to left. At third level, I should do again the left to the right. Okay. So my answer will be something like 3, then 20, then 9. Yes. Then it is as it is, like 15 and 7. Can you understand this? Okay. So this is our output. So it is quite simple, right? Okay. Now, what is the approach to approach this problem? So I can say the first thing is we want to traverse by using what? A level by level. So the first approach is that I can use a level order traversal. Okay. Now, a second thing is that, see here, first we are doing what? A left to right. Then we are doing what? Right to left. Right to left means what? It is like a reverse. That's it. Okay. Then again, it is left to the right. Then again, it will be what? Reverse only. So I can say if, take for example, this level is 0. This level is 0. Then I will say at the 0, it will be left to right. At 1, it will be right to left. Again, 2, it will be left to right. I can say like this, okay? So initially, I can say it will be alternating in sequence. Yes. So in alternating sequence, I should do what? I should do a reverse. Okay, fine. Now let us see how can we do this. Okay, first thing is level order traversal, right? Okay, for level order traversal, we need a queue, first of all. Okay, inside this queue, I place first this 3. I place this 3 first. Okay. Now, anything else in this in that level node, right? So this 3 should be only one node. Okay, I will take this 3 as our output and pop this 3 out. Okay, what are the children of this 3? I can say 9 and 20 are the children. Yes, anything else in that level? Okay. Now, these 2 are the levels. Okay. Now, I will pop this 9 outside and take this 9 as our next level. It is what? The next level. And what are the children of 9 as most level? Okay. Now, again, I will pop this 20 outside and I will place this 20 here. Now, what are the children of this 20? I can say 15 and also 7 are the children of this 20, right? Okay. Now, again, so now these 2 are the next level. So I will pop this 15 outside and put in the next level. Yes. Now, what should I do now? I should improve the children of this 15, right? There is no more children. Okay. Next thing, I should pop this 7 out. Okay. While popping this 7, I should include here also. And whether it is any children, no. So at last, the queue is what? Empty. So while my queue is empty, I should stop here. Okay. And see here, first thing is 7. Then 920. So this 920 will be reversed, right? So if it is reversed, we want to do what? 20 and 9. We want to put what? 20 and 9 like this. Okay. At last we are going and traversing the result, and we are making that into what? Making into a alternating sequence. Hope you understand this, right? And also, it is what we are taking into a result. Yes. Then only we are reversing it, right? Then only we are reversing it. Okay. Can we do this in one single step? Okay. Whenever we are taking this in our result, at that time itself, I will reverse it. At that time itself, I will reverse it by using what? The alternating sequence. For that alternating sequence, how can we do it? So initially take this as 0 and do the XOR with 1. It will be what? 1. Again, take this 1 and XOR with 1. It will be 0. Again, take 0, XOR with 1. It will be 1. Like that. It will be what? Alternating. So I can say whenever my value is 1. Whenever my value is 1, I should do what? A reverse. So at first thing, I don't do reverse. Next level, I will do reverse. At next level, I don't do reverse. I can do like this. Okay. By doing this, we can reverse it and we can store it directly instead of taking the result and then reversing it. Can you understand this? Okay. Right. Now, the second intuition is that a DFS traversal. Okay. Let me write that same note here also. 3. Then 9, 20, 15, 7. 9, 20, 15, 7. So in this TFS traversal, you can use anything like pre-order, post-order, in-order, anything. But the conditions should be clear. Okay. Let me take pre-order traversal here. Pre-order traversal here. Okay. And I will take a dictionary or a hash map to put what is the level, right? Because see here, this is what a 0th level, this is what a first level, this is what a second level. You can also put like 1, 2, 3 also. For my understanding, I'm putting like this. Okay. Now, I want to store that whether this 3 is at 0th level, whether this 9 is first level, like that into this dictionary, such that I will get the reference. Okay. Now, first of all, I'm going to this 3 and initially this 3 is what? Is 0th level. So I will put 0 and put what? 3 here. Yes, then I will go to here, right? In pre-order traversal, we will move to the left first. Then we will come to the right next, right? Okay. Now, while moving to this left, I will do what? +1. So 0 level plus 1, it will be what? 1. So I can found that 9 is at the at the first level. Okay. Now, I will put 1 and include this 9. Right? Then again, I will move backtrack. Okay. Now, again, I will go to 20 and I will put this 20 here. Okay. Then I will move to this 50 and 15 is what? Second level. I will include this 15 here. Yes. Then again, I will backtrack. Then I will move to this 7 and this 7 also included here. Yes. Then I will backtrack and go to the function call. So these are the levels I computed now. Yes. So from this, I can take that in my result, first I will take this 0th level. So whether you want to reverse 0th level, no, right? Okay. So I take this 3 as it is. Okay. I'm taking the first level. Whether you want to reverse it, yes. Yes, we want to reverse it. So reverse it. Why? How we can reverse it? See here. For 0, we didn't reverse it. For 1, we reverse it. For 2, we didn't reverse it. So I can say for odd numbers, for the odd level, we want to reverse it, right? For odd level, we want to reverse it. Okay. And then again, 15 and so on. So this should be my output. Yes. So we can do this using what? A pre-order traversal also. Okay. Now, what is the time constraint for the above approach and below approach? The time constraint for the above approach is that I can say I'm using a queue. I'm just traversing all entire node, right? So it will be O of n. Okay, I'm using a queue. So space of t will be what? The maximum elements in a single level. Okay, or maximum nodes in a single level. Okay, so this is the timer space constraint. Now, going to the next approach is that it has a timer space of day, like I'm of the be O. I'm traversing each and every node, right? I'm traversing each and every node. And if I take this dictionary also take a log and time constraint. But instead of this dictionary, we can use an array or vector or array list like that. Okay, by using that, we can ignore this login. Okay, and also in most case only this dictionary will give what? A login. But at some average of best case, it will go up one only by a constant operation. Okay, now what is space constraint? I can say in my space constraint, I'm just traversing in the entire tree for how many references? For the height. So it will be O of x. And inside this dictionary, what is my length can be? It also be x, right? Which will be what? How many levels it will be completed, right? Levels is what? Height. So I can say O of x is the space complexity. So this is my time and space complexity. Let us see the code. See here, this is the code. First thing is I'm doing a BFS traversal. If not route, then I will return it. If there exists any route, then only the control flow comes to this line. Okay, I'm taking the queue and I'm taking a flag value of 0. This will be doubled. Inside it is 0, then 1, then 0, then 1 like that. Okay. Now I'm taking a result. Now while I have my queue is not empty, what should I do? I will take auxiliary space to store the each and every level. Okay. Then for I in range of len of queue, that means what? I'm just traversing in the particular level. Okay, and then node is equal to the parent value of the queue, and if the node has left, just append it. If the node has right, just append to the queue. And then we want to take what? Inside that auxiliary space, we want to take what? That node value. Okay, after executing this for loop, what will be make this auxiliary space contain? The auxiliary space contain that particular levels, all element, right? Okay, now it's time to check whether if the flag is equal to 1. If the flag is 1, what should I do? I should reverse that auxiliary space and store in the result. If it is equal to 0, then I should store as it is. Okay, and then I do what? Flag toggle. I will do a toggle operation on flag by using one XOR 1. Now, I will return the result. Let me submit it. Yes, it is submitted fully. Now, let us see the second approach. See here, this is the second approach, the DFS approach. I'm taking a dictionary first, then I'm taking the DFS, the function. Inside that, I will choose what? A root and also what? A level. Okay, this level will be signified by what? That in which level the particular node is present. Okay, now, if there exists no root, which means what? The root is equal to null, then what should I do? I just return it. And I do a traversal, like I'm doing a recursion call for root.left and root.right by using what? Level plus 1. Level plus 1 means what? At particular root, we are going to left, right? So it will be plus 1. Yes. Then, if level is not in D, then I should take that level and create that in the dictionary like a simple list. Okay. Now, in ordinarily we do what? T of level dot append of root dot value, which means what? We are just appending the root's value inside the dictionary level value. So level will be key and the value will be what? The list of element in that level. Okay. Now I'm calling that DFS what? Taking the level as what? Initially 0. You may take this as what? 1 also. That's your choice. Okay. Now result is equal to empty list. I is equal to 0. I'm taking from the level 0 onwards. Okay. And while I in D. So if it is odd, I should take it as what? A reverse order. If it is even, I should take as it is. Okay. Then I will do what? I plus equal to 1. Then I will return the result. Let me submit it. Yes, it is submitted successfully. Thank you.
This is the amount of dot com.